In this video we're gonna consider manual assembly lines speed of the conveyor as conveyor speed. Okay, so we already know that the manning level is equal to number of workers divided by the number of station. Okay, and a workstation, so if this is a workstation A, workstation B, workstation B, C, and we have a line as a conveyor which is the red line, so this is A, this is B, this is C. So this one, if the length of this one is LSI, L1, LS2, LS3, so this is the length of the station. So L is summation of LSI from I equal 1 to N. Okay, in a system. So this is summation length of a station, summation of all of them. Okay, so L is equal N times LS, which is summation of all number of station divided by LS. If we consider that LS, there is a constant or a standard size of the station. For example, we are gonna define what's known as feed rate. Feed rate, if we have a assembly line, the red line is a conveyor and it has a constant speed conveyor, base part are launched at the beginning of the line at a constant time interval. Therefore, what does that mean? Like you're putting parts on the conveyor at a constant speed, so FP, which is the feed, is equal 1 over TC. I have to remind you the cycle time is a time by which we should process or we should manufacturing part in order to achieve a certain amount of production per period of time. So FP equal 1 over TC, as you would see it here. Okay. As well as we have a constant feed rate on a constant speed conveyor provide a center to center distance between parts. Again, I'm gonna tell you what does that mean. If we have parts here in this drawing, so this is the distance between one and another, the placement of the parts on the system, and it's definitely related to the feed rate, definitely related to the TC, because if you place the unit very far apart from each other, therefore in a way that means that the conveyor is really quick, but if the conveyor is really slow, so you have to place them next to each other. So we have the spacing, SP is equal VC divided by FP. Okay, which is VC times TC value. So this is the center to center spacing between parts, which is the SP value. Okay, and we're gonna define what's known as tolerant time, TT. It's not TS. TT is LC divided by VC value. And I need to remind you that TT, tolerant time, is 1.5 TC. This is the amount, an extra amount of time you would give to the system in order to achieve a certain amount of production. This will all be clear when we start the example. So we have here as well as the elapsed time is number of station times the time we have. So let's consider an example and we have to go back to those equations. So we have an overhead. So here in this example, which is 17.1, okay, so we have an overhead continuous conveyor used to carry dishwasher base part along a manual assembly line. The spacing between appliance, the spacing to start with is equal to 2.2 meter. So the spacing is 2.2 meter between appliance, between one dishwasher and the next one next to it. The spacing between is 2.2 meter, and the speed of the conveyor VC equal 1 meter per minute. Everything is clear so far. The length of each workstation and LS equals 3.5 meters. This is the length of each workstation. There are 25 stations and 30 workers on the line. So we have, this is station 1, station 2, this is station 25, and we have 30 workers on the line. Determines the elapsed time a dishwasher base part spend on the line. Okay, so if we go back to our equation, we have the elapsed time equal total distance divided by the speed of the conveyor. Okay, since we have 25 stations, which is N times LS, so 25 times 3.5 This is divided by VC divided by 1 meter per minute. So 87.5 okay minute. alright يعني ده طول الكونفير ده سرعة كونفير وده طول الستيشن. عندنا احنا 30 ستيشن 25 ستيشن وعندنا كل واحدة طولها 3.5 متر. تاني point we need to calculate the feed rate and the tolerance time. Okay. So feed rate يعني الداش هني عم بيحطوا at which speed they are placing unit on the system. So the feed rate okay from the equation it has the speed of the conveyor times the spacing يعني SP equal VC على FP. نحن we'll do it the other way around. So this will be 1 meter per minute okay divided by 2.2 meter per part 0.455 parts per minute. Okay, this is the feed rate. And the last question is what is the tolerant time? Okay, and the last question is what is the tolerant time, the one we are considering. TT equal LS divided by VC. So we have 3.5 meter per station divided by 1 meter per minute. So it is 3.5 minute per station. Okay. This is 17.2. So now we're gonna consider 17.6. Now we're gonna consider 17.7. So problem 17.7. Alright. A moving belt is used for a product with work content time. We have work content time is 20 minutes. Production rate RP equal 48 units per hour. Assume that the proportion uptime E is equal to 0.96 and the length of each station LS equal 5 meter and the manning level equal 1. We have the belt speed between can be set between, like we have the belt speed is between 1 and 6 meter per minute as a belt speed. Okay, between 1 يعني فينا نسرع وفينا نبطئ الكونفير بهالحالة. Okay, it is expected the balance delay will be about 0.07 يعني هي معناتها EB equal 0.93 1 minus D. Time loss for repositioning equal 3 seconds. Okay, determine the number of stations needed on the line. Determine the number of stations needed on the line. TC equal 60E over RP equal 60 times 0.96 divided by RP 48 units 1.2 minute per unit. This is the TC value. Okay, so and we know the TC equal TS plus TR. Service time equal 1.2 minus TR value is 3 seconds. The 1.2 minute minus 0.05 minute. This is in second. We change it to minute. So TS equal 1.15. The EB equals 0.93. So we're gonna calculate the number of workstation. So as TWC, if we go back to the equation, EB times TS. So this will be equal to 19 station, 18.7 or 19 station. Okay. So now we know the tolerance is 1.5 TT, which is by default TC equal 1.5 times 1.2 equal 1.8 minute per station. Okay, 1.8 minute per station. So 1.8 minutes per station, and we know that TT equal LS divided by VC. Okay. So VC equal LS, which is 5 divided by 1.8. This is 2.778 meter per minute. I need to remind you that the speed can be anything between 1 and 6 meter. So we calculate that TC equal SP divided by VC. SP equal 1.2 times 2.7, 3.33 meter per part. Okay, and this is extremely important to consider. Like if the speed is between 1 and 6, so we could slow down the system, we could decrease the system. But again, I need to remind you, if we reduce the speed of the conveyor, we have to get the parts if we reduce the speed of the conveyor, we have to make the part to put them closer to each other. If we increase the speed of the conveyor, we have to put the part very much apart from each other.